Welcome to the deep dive. Today, we are strapping in for a pretty high-speed journey into Avalanche, or AVAX.
Yeah, it's a fascinating one.
Looking at the sources here, it's really clear this isn't just, another platform fighting for DeFi users. It seems like it's actively trying to be the foundation for some huge names in traditional finance.
That's absolutely right. And the research back we have is interesting because it shows these two sides, doesn't it? First, there's this deep academic background, coming out of Cornell
Right.
that really shapes the tech. But then second, there's this direct practical appeal it holds for giants like JP Morgan, Visa, Apollo Global. It's a whole different way of thinking about how to scale blockchain.
Okay, so our mission today, let's keep it simple.
Yeah.
Just distill the key stuff from all this material. We need to figure out what this technology actually does and, maybe more importantly, why these huge corporations are looking at it, maybe even exclusively building on it for their future plans. Okay, let's unpack this, starting with the basic problem Avalanche says it's solved.
Right, the problem. It's what everyone calls the blockchain trilemma. For you listening, this is basically a built-in headache with early blockchain design.
The trade-off thing.
Exactly. You can usually get 2 out of 3 things right. Speed, which is scalability, security, and decentralization. But getting all 3 at once, that's the tricky part. If you try to make it super fast, you often end up cutting corners on, say, the number of computers securing it, the validators, which isn't great for decentralization.
So it's like a traffic jam designed into the system itself.
Pretty much, yeah. Think of older blockchains like one single massive highway. If you get too many cars, too many transactions, boom, gridlock, fees go way up, waiting times get ridiculous.
Okay.
So Avalanche's main goal, really coming from that academic theory, is to fix that bottleneck fundamentally. They designed a system aiming for a really high throughput, like over 4,500 transactions per second, and with confirmations that are basically instant and crucially irreversible. All while, at least in theory, being able to support millions of validators.
Okay, that speed sounds amazing, but hang on, we've heard big speed claims before, right?
Yes.
Solana, for example, always talks about huge transaction numbers. What makes Avalanche's approach different? Or maybe more reliable, especially if you're, like, a bank?
That's a really good point. The key difference is the architecture, how it's built. We can use a simple analogy here.
Okay, I like analogies.
Instead of thinking of Avalanche as one huge, maybe slow, general store doing everything, think of it more like a modern, specialized shopping mall.
A shopping mall? Okay.
Yeah, with different wings designed for specific things. This is what they call its heterogeneous architecture.
All right, walk me through this mall then. What are the different wings?
So the main network, they call it the primary network, that's the mall itself, and it's split into these specialized chains.
Okay.
First, you've got the C chain, that's the contract chain. Think of this as the busy public smart contract wing. It's where most everyday stuff happens, DeFi, trading, popular apps. And really important, it's fully compatible with Ethereum's tools, the EVM.
So easy for developers to move in.
Exactly. It makes it the public square super easy for existing projects to just port over.
Right. So C-Chain is for the public stuff. What about managing the mall?
Good question. That's the P chain, the platform chain. It's like the mall's central management office. It coordinates everything, handles the security deposits, what we call staking,
Right.
and it governs how new wings or stores get added.
Okay, management.
And the third.
And then there's the X-Chain, the exchange chain. This one's optimized purely for one thing.
Yeah.
Really fast, simple asset swaps, like a currency exchange counter.
Wait, I have to stop you there, though. Why split it? Why not just one chain? If I'm a regular user and I have to actually move my money, my assets, between X, P, and C just to do something basic like stake, isn't that, well, confusing? The reports later flag that as a risk.
Right.
A bad user experience.
You've absolutely hit on one of the biggest early criticisms, that complexity hurdle.
Yeah.
The short answer is they split them up for maximum specialization and speed.
They wanted the P chain only doing governance and staking, the X chain only doing fast transfers, without getting bogged down by, say, complex smart contracts running on the C chain. So while, yes, it is confusing for newcomers, the upside is supposed to be the stability it brings to the whole network.
Okay, I see the trade-off. Let's pivot back to why the big institutions are interested then. This separation seems to lead right into the idea that attracts them. The subnets.
Exactly, the subnets. Now, these are basically customizable, sort of application-specific blockchains. Think of them as L1s that borrow their security from that main primary network. This is the key to getting institutions on board.
Right.
It's like letting a huge corporation, say a big bank or a massive game publisher, open its own private, highly specialized, super secure, sovereign store right inside the mall.
A sovereign store. Okay, that sounds serious. But why do banks need sovereignty on a public network? What does that even mean?
It boils down to control and, crucially, compliance. Think about it. If JP Morgan or KKR wants to tokenize assets, turn real-world things like stocks or private equity funds into digital tokens, what they call RWAs.
Right, real-world assets.
Yeah, they just cannot use the public C chain for that. Why? Because the C chain is open, it's permissionless, it can be anonymous. Banks need to enforce really strict rules, KYC, AML, all that stuff.
So the subnet lets them basically set up their own private rulebook.
Precisely. The subnet uses Avalanche's underlying security, but the institution gets to call the shots inside its own environment. They can demand that all the computers validating transactions in their specific subnet are vetted, maybe KYC-AML compliant.
Yeah.
They could even restrict transactions to only verified institutions. They choose the gas token, the rules, even the hardware requirements for validators. You just can't get that level of fine-grained control on a big, monolithic public chain. And that's why these players are seriously looking at Avalanche's model.
Okay, that makes sense. So the traffic from some massive new game or even Visa settling stablecoins like the reports mentioned, it doesn't jam up the main public C chain for the rest of us just doing simple swaps or whatever.
You've got it. It completely isolates the traffic. It prevents that really critical noisy neighbor problem where one super popular app slows everyone else down.
Right.
This architectural isolation, honestly, that's the single biggest selling point for these corporate clients. They need predictable, high-speed performance just for their own stuff.
Which brings us back to the speed again. How does this whole multi-chain thing plus the subnets actually achieve that almost instant confirmation? The reports talk about the Snow consensus protocol, something about repeated random subsampling. Can you simplify that?
Yeah, let's break down the Snow protocol. Think of consensus fundamentally as voting on whether a transaction is valid or not.
Okay.
In older systems, often every single voter, every validator has to talk to every other validator to reach agreement. So it creates latency.
Right, slow.
Avalanche uses a different approach. It's gossip-based.
Like a well-behaved rumor mill. We talked about this earlier.
Exactly. That's a good way to put it.
Yeah.
When a transaction comes in, a validator quickly asks a small, randomly chosen group of other validators, that's the subsample, what they think. Hey, is this transaction legit? If most of that small group says yes, the validator gains confidence. Then it repeats the process, asking another small random group and another. This gossip spreads really, really fast, iteratively, until basically the whole network is highly confident, almost certain.
And the result of all this gossiping?
The result is that transactions achieve finality, which means they are totally confirmed, irreversible in less than 2 seconds.
Wow. Less than 2 seconds for finality.
Yeah.
Not just likely confirmed, but done.
Exactly. It's not probabilistic like on some chains where you kind of have to wait for a few more blocks just to be sure. It's deterministic and practically instant. And think about it. For high-value stuff like JP Morgan settling tokenized bonds, they can't afford to wait 5 minutes wondering if it went through.
No way.
They need absolute certainty fast. That's why the Snow consensus is really the engine behind that whole institutional pitch.
And here's where it gets really interesting for me looking at the notes. This consensus mechanism, it's also leaderless, right? There's no single central coordinator telling everyone what to do.
Correct.
And apparently you can scale up to potentially millions of validators without slowing down.
That low communication overhead is the secret sauce there.
Yeah.
It means they can, in theory, get really high decentralization without that typical performance hit. It's their elegant answer to cracking the trilemma they set out to solve.
Okay, let's shift to the practical side for users. If I, as a consumer, maybe I'm playing a game or using a DeFi app built on an Avalanche subnet, what am I actually going to experience day to day?
Well, mostly you're going to experience speed and low cost. Two main things. First, near instant confirmation. You click send or buy or whatever in your app and boom, it feels done. That makes things like gaming or trading feel much smoother, much more responsive.
Yeah, no more staring at a pending transaction spinner.
Exactly. Second, the cost. Transaction fees are typically very low. The reports mention averages around, $0.20 per transaction. Very cheap compared to some other networks.
Go cheap and fast.
Right.
But what about that institutional backing? That seems to be the really big signal for stability and maybe long-term potential in these sources.
It really is the ultimate kind of B2B validation, isn't it? And we are seeing significant momentum that suggests the subnet model actually works for these regulated players. You mentioned Visa. They're actively using a dedicated subnet for stablecoin settlement experiments.
Right.
Deloitte is using the platform for making disaster relief claims more efficient and transparent. And then in the big finance world, private equity firms like KKR and Apollo Global Management are running pilots, testing how to tokenize private funds using this specific infrastructure.
So it's really moving beyond just being a crypto playground. It's actively being built out as this customizable, reliable infrastructure for some absolutely massive global corporations. And they're using it for real business processes, not just, throwing up a test website.
Precisely. The vision they talk about is tokenizing essentially all global assets. It's a huge ambition.
Of course, every big project, especially one trying to carve out such a specific niche like this, faces risks and has weaknesses. What are the main challenges or criticisms that come up in these reports for Avalanche?
Yeah, absolutely. The reports highlight, I'd say, three main areas of risk. The first one is just fierce market competition. And interestingly, the sources stress the biggest threat isn't necessarily the original, maybe slower layer 1 Ethereum itself,
Oh,
but rather those really fast, really cheap layer 2 solutions that are built on top of Ethereum. Things like Arbitrum, Optimism.
the layer twos, the Ethereum moat, some call it. They offer similar speed, maybe even cheaper sometimes, but they get to piggyback on Ethereum's enormous liquidity pool and its, battle-tested security. That's tough competition.
It absolutely is. Avalanche has to build its own liquidity, attract its own users, pull them away from that very established, very liquid Ethereum ecosystem. It's definitely an uphill battle there.
Okay, competition. What's number two?
The second risk is around internal centralization. Critics often point directly to how the AVAX token was initially distributed.
Yeah, I saw that number. Something like 40% of the initial tokens went to insiders, the team, the foundation, early investors. Why is that seen as such a big deal?
Well, it translates pretty directly into governance power, doesn't it? If nearly half the voting power effectively sits with a relatively small group of insiders, this so-called insiders club, it naturally raises questions about how truly decentralized the network is and who really controls its future direction, potential upgrades, that sort of thing. And tied into this, we come back to that complexity point you raised earlier.
The XKC chain thing.
Yeah, that three-chain setup, honestly, it does create a genuinely confusing initial experience for new retail users. It's a barrier. How do you move funds? Why do I need to? It definitely hinders broader mainstream adoption.
Okay, so competition, centralization concerns, user complexity, and the third big one, the elephant in the room for pretty much all U.S. crypto projects, regulate.
Absolutely. Regulatory uncertainty. It's systemic, especially in the U.S. The lack of clear rules from regulators like the SEC means there's this constant, you could almost call it existential risk that AVAX or tokens like it could suddenly be classified as an unregistered security. If that happened, it would severely restrict how it could be traded and used in the U.S. markets. That could seriously undermine the institutional growth they're working so hard to achieve.
Wow. Okay, so that is a complex picture. Incredible tech, clearly tailored for big institutional needs, but facing real hurdles with competition, governance questions, user experience friction, and this looming U.S. regulatory cloud.
It's definitely a tightrope they're walking, no question.
Before we wrap things up, let's just quickly touch on the token itself, AVAX.
Right.
What actually gives it value in the long run, apart from just being used to pay transaction fees?
Right, the tokenomics. They're actually designed to be strongly deflationary, which is quite interesting. So AVX is used for, yes, all network fees. It's also required for staking. Validators need to lock up a minimum of 2,000 AVX to secure the network. And it serves as the kind of base currency for launching and operating these subnets.
And that deflationary edge you mentioned, how does that work? Does the supply actually go down?
Yes, potentially. It works through a mechanism called burning. And here's the crucial part, which is different from many other networks where fees often go to the validators or miners. On Avalanche, 100% of all transaction fees from the C chain, P chain, X chain, even potentially fees within subnets, depending on how they're set up, are permanently burned.
100%, gone forever.
Gone forever, removed completely from the circulating supply. The implication is pretty powerful. Every single time the network gets used, whether it's a simple DeFi swap on the C chain or a massive bond settlement on a JP Morgan subnet, it creates deflationary pressure on the AVX token.
So wait, that means the high volume of corporate and gaming traffic that Avalanche is trying so hard to attract actually directly contributes to making the AVAX tokens scarcer over time. That really ties the success of the whole ecosystem, especially their institutional strategy, directly to the potential long-term value of the token for anyone holding it.
It creates a direct economic link. It aligns the incentives. Network usage drives token scarcity.
We've just sort of unpacked the snow consensus and these pretty unique deflationary tokenomics. If you appreciate us trying to simplify these complex bits, breaking down why institutional money might care about specific token features.
That's right. If you're enjoying how we break down these complex projects into simple pieces and want more reviews just like this, make sure you subscribe to our channel, CryptoBox. We do all the complex research so you don't have to.
So after all that, what does this all mean? Can you boil Avalanche down into just one sentence for the listener?
Okay, one sentence. Avalanche is a highly performant and uniquely flexible multi-chain infrastructure. It's really distinguished by its novel consensus mechanism and that sovereign subnet architecture, positioning it as potentially the preferred platform for big corporate clients who need custom high-speed blockchain solutions, especially for digitizing global assets.
And maybe the final thought to leave you with digging into these sources is the core question Avalanche really forces the industry to ask. When the world's most complex, high-stakes financial systems, the JP Morgans, the Visas, finally move onto blockchain, will they choose one massive, public, one-size-fits-all chain? Or will they prefer a network of specialized, highly controlled, custom-built sovereign chains designed just for their specific needs? That's the fundamental battle for the future of corporate infrastructure that Avalanche is fighting right now.
It's a fascinating strategic bet they're making.
Absolutely. Until the next deep dive, thanks for tuning in.